Hi, welcome to my topic Circuits and Networks. I am Ravikant and today we are going to discuss about mesh analysis and node analysis. Let us start our problem with introduction of mesh analysis. You can see as the problem number 1 for the circuit shown below in figure, find the loop currents using mesh analysis, estimate the voltage developed in 3 ohms and calculate the power developed in 2 ohms. So this is a circuit given to us. What we need to find? We need to find out loop currents. They are also called as mesh currents. Then we have to estimate the voltage across 3 ohms and calculate the power developed in 2 ohms. So here we do need to calculate the power and here we need to calculate the voltage. So we'll start off with applying mesh analysis for the given circuit. Before applying mesh analysis, you should know about KVL. We have to apply KVL in these 3 loops. We have 3 loops here, so we have to apply KVL in these 3 loops. And KVL is elaborated as Kirchhoff's voltage law. It states that the algebraic sum of all voltages in any closed circuit or mesh or loop is 0. Since we have 3 loops, by applying KVL for 3 loops, we will get 3 loop equations. Here we are assuming all the loop currents flowing in clockwise direction. So this is the loop 1 here, this is the loop 2 here, and this is the loop 3 here. We have 3 loops here. So the loop currents which are going to flow in these 3 loops are I1 in clockwise direction, I2 in clockwise direction, and I3 in clockwise direction. So when the currents are flowing in clockwise direction, we have to apply KVL to the individual loop. So here we are going to start off with 10 volts. Then we are going to go through 6 ohms where the voltage will be developed in this fashion. And then the current will come into 1 ohm where the voltage is going to develop in this fashion. When you are going to have a drop in 1 ohm, then the value of current which is flowing in this particular branch will be I1 minus I2. Why I1 minus I2? Because we are taking loop 1 as the dominating loop and loop 2 as the least dominating loop. So that is why we are going to take I1 minus I2. When we are going to make into the loop 2, that is when you are going to apply the KVL for the loop 2, then we are going to assume that loop 2 is dominating and the other 2 loops will be least dominating. So here we are going to apply KVL. So minus 10 is the given voltage source, plus 6I1 is the drop across 6 ohms. Then you have 1 ohm and you have current I1 minus I2. So 1, which is resistance, multiply the difference of the current, will give you the drop across this particular branch. So that is equal to 0. The same case will start off with loop 2. In the loop 2, when the current is going to travel from higher potential to lower potential, this is how it goes through 1 ohm and the value of the voltage drop will be 1 into I2 minus I1. Then the current will flow in 2 ohms and the drop of the voltage will be across 2 ohms, that is plus in this side and minus in this side. And if at all the current has to travel to 3 ohms, then the current will be developing as I2 minus I3. The same case what we have followed for loop 1. So here the conditions for voltages, this is how we are going to get 1 I2 minus I1 plus 2 I2 plus 3 I2 minus I3 equal to 0. Therefore we are satisfying the KVL for this loop 2. Then we are going to enter into the loop 3. Here you have 3. So 3 is there and loop 3 is there. So we are going to consider loop 3 as a dominating loop. Then the same current is going to flow through 10 ohms, that is I3, and it is going to flow in 20 volts also in this fashion. So the KVL when you are going to apply for this particular loop 3, we are going to get as 3 I3 minus I2 plus 10 I3 plus 20. You have to take the voltage symbol which is plus on this side as it is. Whatever it is coming on the path, you have to take as it is the voltage. It is equal to 0. So you have to simplify these equations. Then you're going to get as this equation minus 10 plus 6I1 plus 1I1 minus I2 equal to 0 will be changing to 7I1 minus I2 is equal to 10. This I am considering as equation 1, followed with second equation. This is 1 I2 minus I1 plus 2 I2 plus 3 I2 minus I3 equal to 0. So this goes as minus I1 plus 6 I2 minus 3 I3 is equal to 0. So this will take as equation 2. And finally we have this third equation which is 3 I2 minus I1 plus 10 I3 plus 20 equal to 0, which gives us minus 3 I2 plus 13 I3 is equal to minus 20. Now this is equation 3. So you need to solve 1, 2, 3 equations, 1, 2, 3 equation in order to get the values of the currents, that is loop currents. I1 is equal to 1.34 amperes, I2 is equal to minus 0.617 amperes, and I3 is equal to minus 1.68 amperes. So this is how we calculate the loop currents using mesh analysis. Now the second goal of our problem is to find out the voltage developed across 3 ohms. Mind you, we need to find out the voltage in 3 ohms, which is the situated between loop 2 and loop 3. Therefore, the current which is going to travel will be I2 minus I3, and the power which is going to be developed across 2 ohms will be having the impact of the current which is flowing in 2 ohms, that is I2. So mesh loop or currents are already calculated as I1, I2, I3s. So we are going to have voltage across 3 ohms, that is 3 into I2 minus I3, which is equal to 3 times of this. You can see I2 value is minus 0.617 amperes. Again you have minus here, so minus of this particular I3 minus will give you the value as plus, so plus 1.68. so this sum with this product 3 will give you the value as 3.189 volts. So that is the value of the voltage drop across 3 ohms. Similarly, we have to estimate the power developed across 2 ohms. The formulas which are useful for power are V into I, or that is can be written as I square R, or it can be written as V square by R. So we can employ any of these formulas to get the value or the power which is going to be developed across 2 ohms. So let us take I square, which can be termed as I2 square, into R, which is nothing but R2, the value of resistance 2 ohms we are going to consider. So here you can see power developed across 2 ohms is equal to I2 square, which is the second loop current, into R2, and that is equal to minus 0.617 square into 2, which gives us the value as 0.761 watts. So this is how we solve the problems using mesh analysis. Let us introduce now here node analysis. Node analysis is a technique which is going to be employed based upon KCL. So you have to identify the node points first. For this particular loops, these are the node points where you can have node 1 with voltage value V1, node 2 with voltage value V2, and you can have a reference 0 volts. So we can define KCL at these particular nodes with algebraic sum of all the currents at a particular node. This is node called, or a point, you can refer this one as a point, or at a junction is 0. So apply the KCL at these node points in order to get the solution for node analysis. So we are going to apply KCL for node 1 here. Then we are going to get C. V1 is the voltage which we have selected, assuming this to be at higher potential and the rest of the voltages at the lower potential. So I am considering V1 minus 10. V1 minus 10 because the lower potential minus sign is situated at the bottom. So that is why V1 minus 10 by this 6. This 6 is the branch resistance of this particular branch. So you have the branch current here, that is V1 minus 10 by 6. This is one branch current. Then you go for this branch. You have V1 minus 0 by 1. So this is V1 by 1, nothing but it is a current in this particular branch. Then you can go for V1, this is this particular node, minus V2, this another node, by 2. So this is another branch current. So you can have 3 branches to this particular node, that sum should be equivalent to 0, thereby satisfying the definition for KCL. So simplifying this, we have 5V1 by 3 minus V2 by 2 is equal to 5 by 3. So this is equation 1. Similarly, applying KVL at node 2. At node 2 also you have 3 branches. This branch, and this branch. So V2 minus V1 by 2 is one branch current. V2 minus 0 by 3, this is another branch current, and V2 minus 20 by 10, that is the another branch current. So satisfying the KCL, which is equal to 0, and simplifying this equation, we are going to get minus V1 by 2 plus 14 V2 by 15 is equal to 2. Now consider this as second equation and rearrange equation 1 and 2 in order to get a better solution. So I have changed it to decimals. 1.66 V1 minus 0.5 V2 is equal to 1.66. I am taking this equation as 3. So equation 1 is changed to equation 3. Likewise, equation 2, which is here, can be changed to minus 0.5 V1 plus 0.933 V2 is equal to 2. Now this is another equation. Second equation is changed to fourth equation. Now simplify equation 3 and equation 4. We are going to get the value of V1 as 1.96 volts, V2 as 3.195 volts, and current we have to calculate in 3 ohms. Mind you, what was the current which we have calculated in 3 ohms using mesh analysis? It was I2 minus I3 multiplied with 3. So here we have to calculate current in 3 ohms using node analysis. So it will be V2 by 3, because V2 minus 0 by 3 is the branch current over here. So in node analysis, we have to follow this method. In mesh analysis, we have to follow that method. So you got the value of V2 by 3 is equal to 1.065 amperes. So this is how we calculate the current in 3 ohms using node analysis. Let us focus on the next problem, which is we need to find out the branch current in 6 ohms. We have to find out the branch current in 6 ohms. So we are identifying the loops in clockwise directions, all the loops. If at all you want, you can take anti-clockwise direction also. Later you can interpret the results. First you get the solution, and later you can apply the anti-clockwise direction of the currents. Check out the magnitude of the currents. You should get the same value. Now here you can see, when I'm considering loop 1, fortunately we have 6 amperes here. It is the current source. So the branch current which is flowing from this point to this point is nothing but 6 amperes. That is itself is becoming as the loop current. So I1 is equal to 6 amperes. That we have to take as conclusion 1. Then applying KVL to loop 2. Here we have to apply KVL. So we will start off with minus 36 volts. Likewise, we have to solve the same problem in the previous case. So minus 36 plus 12. I2 minus I1. I told you the loop which you have selected, that loop you have to consider that point of view as the dominating loop. That's why it is I2 minus I1 multiplied by 12. This becomes one drop over here. So it is another voltage drop. Then you have 3I2, which is here. Then you have 6. You have this branch shared by I2 and I3. So 6 I2 minus I3 equal to 0. So this is how you simplify this equation such that you left over with minus 12 I1 plus 21 I2 minus 6 I3 is equal to 36. This we have to consider as equation 2. Then applying KVL to loop 3. When you are going to apply KVL to loop 3, you are going to get 6 I3 minus I2 plus 5 I3 plus 9 equal to 0. This you can simplify and make it to equation 3. So you have equation 1, 2, 3. So solving equations these 3, we get I1 already we have 6 amperes, I2 we are going to get as minus 2.307 amperes, and I3 are going to get as minus 2.076 amperes. We have to find out the branch current through 6 ohms, which is over here. So it is nothing but I2 minus I3. So minus 2.307 minus of minus 2.076, which gives the answer as minus 0.231 amperes. So this is how we sort out the branch current problem using mesh analysis. You can check the same result with applying node analysis. Therefore, taking the help of KCL, you will get the solution and check the result whether you are going to get minus 0.23 amperes or not. Let us concentrate on the next problem, which is in this fashion. Here you have loop 1, here you have loop 2, here you have loop 3. So I am taking the loop current directions randomly. In the previous problems, I have selected 1, 2, 3 loops as clockwise directions. Let the loop 1 is in the clockwise direction. Let the loop 2 in anti-clockwise direction. And let the loop 3 in clockwise direction. So you can have these combinations in your own way. Make sure that the magnitude of the current is not getting changed. Though the direction of the current is changed, magnitude will not change. So after identifying the loop current directions as I1, I2, I3, applying KVL to loop 1. So minus 10 here, plus 4 I1 plus 3 I1 minus I3 plus 1. Here you can see branch which is going to have the current in 1 ohm, that is the I1 as well as I2, and both are acting on the same direction. This is I1 coming from top to bottom, I2 is also coming from top to bottom. That is why it is I1 plus I2. So simplifying this equation, you are going to get 8I1 plus 1I2 minus 3I3 is equal to 10. This you consider as equation 1. Then applying KVL to loop 2, minus 8 plus 2, I2 plus I3. You can see here minus 8 we have started from here, plus 2. See, this is in Anti-clockwise direction, I3 is in clockwise direction. That is why this 2, I2 plus I3 plus 1. Here also you can see I1 and I2 both are acting from top to bottom. So that is why I2 plus I1 equal to 0. So simplifying this equation will give you the value as I1 plus 3I2 plus 2I3 is equal to 8. Considering this as equation 2. Going with third loop, this loop. And I am going to start with minus 12. So minus 12 plus 5I3 plus 2. Here you have 2. I3 plus I2 plus 3 here. Here you can see 3. I3 minus I1. Why I3 minus 1? Because I1, I3 loop directions are in clockwise. That's why the loop which you are going to consider, that is a dominating loop, and the loop which is having the shared resistance value will be least dominating. That is why I3 minus I1 equal to 0. Simplifying this equation, minus 3I1 plus 2I2 plus 10I3 equal to 12. This we consider as equation 3, and solving these three equations we will get the value of I1 as 1.66 amperes, I2 as 1.13 amperes, and I3 as 1.47 amperes. We have to make sure that I3, which you are going to get as 1.47, whether you employ node analysis or mesh analysis, you should get the same value of current which is going to be flowing across 5 ohms. So we are going to apply now node analysis. Before that, we have to identify the nodes. We have here 4 nodes. Node 1, 2, 3. Another node you have reference, it is in the groundward directions. Let me name these nodes as V1, V2, V3, and I'm taking a reference node whose value is 0 volts. So total we have 4 nodes, and 0 volts is the fourth node which is shared between V1 0, V2 0, V3 0. So every node has 3 branches. Observe here, you have V1 here, and there are 3 branches. One is this branch, one is this branch, and one is this branch. Similarly, V2, you have 3 branches. Similarly, V3, you have 3 branches. And observe here carefully, what is the V3 value? See, plus and minus, which is 8 volts, it is connected directly between third node and reference node. The minus sign is at 0 potential, the plus sign is at V3 potential. So directly the value of V3 will be 8 volts. You have to remember this point. Here V3 you have 8 volts. Okay. So we need to concentrate on V1 and V2. So applying KCL at node 1, this particular node you have V1 minus 10 by 4, V1 minus 10 by 4 plus V1 minus V2, V1 minus V2 by 3 plus V1 minus V3, V1 minus V3 plus is towards V3, that's why it is taken as plus here, divided by 5, which is equal to 0, and this is the current which we require in 5 ohms. So this is the branch current. Remember this branch current equation. Now we are simplifying these equations. We are getting as 0.78 V1 minus 0.33 V2 minus 0.2 V3 equal to 0.1. So we have to remember that V3 is 8 volts, what we have considered here. Substituting the value of 8 over here, then you are going to get the value as 0.78 V1 minus 0.33 V2 is equal to 1.7. Because this minus 0.2 multiplied with 8 will give you as minus 1.6. Take that 1.6 on the right hand side, you will get 1.7. So we have considered this equation as 1. Similarly, applying KCL at node, this particular node. So you can see V2 minus V1 by 3, V2 by 1 plus V2 minus V3 by 2 equal to 0. So simplifying this equation and identifying that V3 is equal to 8 volts, you are going to get minus 0.33 V1 plus 1.83 V2 is equal to 4. This is equation 2. So we have equation 1 as 1.74. In terms of equation 2, you have 4. And these are the V1s and V2s arrangement. And V3, you remember, we have 8 volts. And simplifying this, we'll get the value of V1 as 3.36 volts, V2 as 2.79 volts. And current in 5 ohms will be equivalent to, I told you to remember this current direction, V1 minus V3 plus 12 divided by 5 will give you the value as 3.36 is the value of V1 minus V3. What is V3? 8. So minus 8 plus 12 by 5, which will give you as 1.47 amperes. Remember this current, we got the same current as I3 current while applying the mesh analysis. So this is how you check out the results once you obtain the final answer. The magnitude of the current, whether you apply mesh analysis or node analysis, you will get the same answer. Some more numericals will solve in further classes. And if at all you are happy with this particular video, then please like it, share it, subscribe among your friends, and press the bell icon for the further notifications. Thank you.